You missed it. All right. Partial fractions. So what I've done for you right here is I've written f of x, the function x plus 13 over x squared minus x minus 20, and I've broken it down into what are called partial fractions. Why is this important? So here's one of those topics like, why do we have to learn this? Because it's going to help you for calculus, y'all. So in calculus, you will have a curve and you will have to find the area under a curve. If that function happens to be this kind of fraction, it is very difficult to find the integral of this. You would actually have to separate it into what is called its partial fractions. If you don't separate this into its partials, you cannot take an integral of it. So again, you're like, okay, well, can I just wait until then? No. So we learn it now in PreCalc how to what's called decompose into partials. And then when you get to calculus next year, you will learn how to integrate and decompose those two partials. So by definition, partial fractions, all that means is that you have two or more fractions that originally add to f of x. So these two fractions added to this original function right there. That's all a partial fraction is, and that's all we're doing today. We're going to learn to decompose it. Next year, you'll learn to integrate them then and find the area under a curve, which will be so much fun, okay? All right, so decompose, I should say, into partial fractions. Let me move this up. There we go. Example 1, and your f of x equals, actually it's f of y. 8y plus 7 over y squared plus y minus 2. Okay, so the first thing you're going to want to do is take the denominator and factor it down so that way you can actually see what the actual two denominators or three denominators could be. So if I factored this down, this would factor into what? I know we have to think now. What two numbers multiply to negative 2 but add to 1?
1 minus plus 2 minus 1.
Yeah. Okay. You will then take those two. Those will become, each of them is your new denominator of the partials. So y plus 2 is one of the denominators, y minus 1 is the other one. Above that, you will put the letter A and B, and it doesn't matter where. You could use C and D, whatever. A and B is what I have. So let me write this in steps for us so that way we can kind of, if we ever have to go back to your notes, look to see what we're doing here. So step number 1, you want to factor the denominator and write as separate fractions. Factor the denominator, God bless you, write as separate fractions. And then I'm just going to write step 2 here, which is the next step we're going to do. You want to now solve this so that we have no fractions at all. We actually want to get rid of the fractions. And we do that, we eliminate the denominator by multiplying by the LCD. So we're going to get this so that we don't have any denominators. So what is the LCD? Again, you've done this before. This was in your last chapter. I would give you something like that. Obviously, there'd be like, x or y, and you'd multiply and solve for x. We're not solving for x. We're actually solving for a and b. That's what we're actually solving for. So what would be my common denominator? What would it be?
2.
Y plus 2 and? We need both of them. Yeah, it's always going to be this, y'all. It's always going to be whatever you decompose it into. So, and again, the way that I do it is, and I know some of you don't like it this way, but I promise you it helps. If you put it onto the top, because that means you're multiplying, y plus 2 y minus 1, y plus 2 y minus 1, y plus 2 y minus 1. There's methods to my madness. This would cancel with this one, this would cancel with this one, and you would just be left with 8y plus 7 equals. Then this y plus 2 would cancel with this y plus 2, and what would you just be left with? A, and what else? Y minus 1. We'll distribute that. Actually distribute the A. So you would actually be left with AY minus A. This Y minus 1 would cancel with this Y minus 1, and I'd be left with a B and a Y plus 2, or what would you say? BY plus 2B. Yeah, you could call it B2, but I'm just going to go 2B. Now, this is great. Now I've eliminated the denominators. It doesn't look so ugly to me. And so now we're going to do our step 3, which is the most important part. So I want you to kind of come with me about equations, which you may not have realized. If you have an AY on this side and a BY on this side, according to an equation, which is an equals, these two together should equal 8y. Wouldn't you agree? So this should be like 7y and 1y, or this would be 5y and 3y, or whatever, right? No matter what, though, they should equal 8y. Well, you're going to write that down. AY and the BY should equal the 8y. Then what could you say about the negative A and the positive 2b? What should they equal? 7. That's what equation property says. This should equal this. All the x's on this side should equal all the x's over here. All the numbers by themselves should equal the numbers by themselves here. So negative A and 2b should equal 7. What have I just created? A system. More particularly, a system that you could solve with a matrix. That is why this is in the matrices chapter. Okay? So let me call that step 3. Let me explain what we just did. I combined terms into a system and create a matrix. So what would be this augmented matrix here? What would be my top row of numbers? What would I have? 118. 1B, 18. The bottom would be -1, 2, and then 7. In your calculator, you would RREF this, or some of you like the A inverse B still, whatever you used to do, that's fine. And I like RREF, it makes it easier. You should end up with the identity matrix right here, 1, 0, 0, 1. And then I'm going to give it to you because I'm going to assume you all know how to do this. We've been doing this for last class. You're going to get a 3 here and a 5 here. What does that 3 represent? What is it? A. It's not X. You didn't solve for X. You solved for A. This is A. Then what's this guy? B. Now, if you gave me the answer as 3 and 5 on the test, you'd be wrong. Because the question said, again, to decompose into partials, fractions, meaning you found out what the denominator was, now you found out the numerator. If you gave me 3 and 5, all you did was give me a numerator. So what would be the actual fraction? What should 3 be over? Y plus 2. And what should B be over?
Y minus 1.
So 5 over Y minus 1. This right here is the answer. This is step 4, rewrite as a fraction. Or I should say rewrite as the correct fraction. Okay, so that is your answer. That is the decomposition of that f of x. If you were to add these together right now, you would get 8y plus 7. How do you feel about that?
Great.
I mean, is it a lot to do? Yeah, but it's doing everything you did before in the past. You have to multiply by common denominator. You're creating this new matrix, and then you are already fit. All right? All right, cool. So one more thing, and then we done. All right. There's this thing about powers, though, with partial fractions. So if I had like 5x minus 1 over x cubed times x minus 1 squared, and I said decompose that into partial fractions, we have a problem with powers. Because powers, again, we're talking about your future in your calculus career. When you start to try to integrate them and everything like that, your partial fractions need to be singularly all the way down to 1. So here's what I mean. What you would actually do is you would take this factor and you'd write it as a over x cubed. Totally do that. But then you actually have to include a b over x squared and a c over x to the 1. You have to have all the powers of this factor down to 1 every time, unless the power is already 1, which it was in my other example. The power of each one was already 1. So then this factor, this x minus 1 squared factor, you would then have d over x minus 1 squared and an e over x minus 1 to the 1. So here's the problem in short. And this is just rule, y'all. It's not, Mrs. Seta, isn't there any other way easier? No, it's just the rule to create it into partials. The rule says that when you have factors, or when factors have powers, you must include each power from the highest degree all the way to 1. If you have a fraction and the denominator has anything greater than 1 as a power, if it was x to the 5th, you'd have to have a partial fractions of x to the 5th, x to the 4th, x to the 3rd, x squared, x. Is it annoying? Yes, but it's just the way we decompose, okay? Would I ever give you one like this? No, probably give you it never. I mean, maybe for bonus I should do it though for some time. All right, so let's do one more of these. Decompose x plus 2 over x cubed minus 2x squared plus x into partials. And again, for those of you not going on to calculus, today is a moot point in your career. It's pretty much talking to a person.
So I should just not even do it?
No, I'm just kidding. You have to do it. You have to get graded on this.
Just give me 100.
Okay.
I need it.
Speaking of which, for these two sections, today and Monday's section, I'm not giving you a quiz. I'm giving you a worksheet, which you will be graded for homework, and then you'll just hand that in. Because I don't want to stop and do a quiz on these two. I just want to get into chapter. We actually are going backwards. We're going back to chapter 3 and doing logs and exponents. So that's been really, really fun. All right, so let's take our denominator here and let's decompose this. What can I factor out of the bottom?
X.
An x. And I'm left with x squared minus 2x plus 1. What does that factor into? Two numbers multiply to 1, but add to a negative 2. X minus 1, which is x minus 1 squared. Okay, so there we go. We have a power that is bigger than 1. So when I go to write my partials, I would have a over x. That's already a power of 1, so I don't need to go any further down. I would have b over x minus 1 squared, and this is what everybody would forget, but then you have to add another partial c over x minus 1 to the 1. All your powers must work themselves all the way down to 1. Okay, it's just the rule. All All right, so someone tell me what we did once we got to this step. What was that? What we do in our other problem after this? We multiplied by what? LCD. What is my LCD? X times x minus 1 squared. It's always this guy. It's usually always your LCD. So I'm going to take this, multiply by x times x minus 1 squared. I'm going to take this guy, x times x minus 1 squared. And I know, again, this seems annoying. Why do I have to do this? If you do it right every time you do it, that's fine with me. But I'm pretty sure I've caught many people do it wrong in here. This cancels, so I am just left with x plus 2. Beautiful. The x and x cancel here, and you're left with a times what? X minus 1 squared. Are we going to FOIL that out and distribute? Yeah, in a minute. We'll just wait for that. X minus 1 squared, x minus 1 squared. So what am I left with here? Bx, right? X minus 1 to the 1 times x minus 1 squared means I still have an x minus 1 quantity. So I have c, x, and an x minus 1. So now you got to do a little bit of math. It's the joy of this class, I know, right? Okay. X minus 1 squared, you do have to FOIL it, but if you notice, it was already FOILed over here. Okay. X minus 1 squared is x squared minus 2x plus 1. And then you do need to multiply a through on that. So that would be ax squared minus 2ax plus a. Bx, you don't need to do anything to that. Just put bx. Cx times x, what's cx times x? Cx squared minus cx. Okay, now listen to me. You're going to combine your terms not by a's and b's and c's. You're combining them by x squareds, by x's, by numbers. Okay, so here's what I mean. I have an ax squared and a cx squared. Do I have an x squared over here? So what do I set them equal to?
0.
So I have ax squared, I'm actually going to leave a space, there's a reason for, plus cx squared equals 0. All right, now let's go to my x's. I have a negative 2ax, I have a bx, and I have a cx. Negative 2ax, a bx, and a minus cx. And what should they equal? What do they equal on this side? 1x. All the x's equal all the x's on this side to side. All right, and then I have just an a over here. What should it equal over here? 2. That's actually cool. We actually know that a is 2, by the way. All right, now you need to write this as a matrix. What would be my matrix top row numbers? I have 1ax squared. Do I have any x squareds for b's?
No.
0. 1cx squared, 0. 1, 0, 1, 0. What would be the middle row? That one's easy. Negative 2, 1, negative 1, 1. And then what would be my last row? 1. Do I have any b's or c's? 0, 0, 2. You would RREF this, okay, or A inverse B. I like RREF. And I'm actually going to show you what you should get. How about that? Because I know you're all like, I'm glazed over, Miss Aceta. I don't want to punch it into my calculator. Although, Ben, you would, wouldn't you, for me? Of course you would. You should get the identity matrix right here. You have to get the identity matrix. If you don't, you have an inconsistent system. Then you will get these 3 numbers. You'll get a 2, a 3, and a negative 2. And again, what are those 3 numbers representing? Well, this is your A, that middle is your B, and that middle is your C. But you have to write it correctly in its decomposed form. So what would you put? 2 goes over what? X. Look back up here. 2 goes over X. B, which was 3, goes over the x minus 1 squared. So 3 over x minus 1 squared. And then your C, I write it like this. I just write negative 2 on top. goes over the x minus 1. And if you were to add these, you would get the original function. Now you can see why I only gave you 5 problems for homework tonight. Yeah. All right. So do this, or do your whatever you got